When working with derivatives, sometimes different functions will overlap with each other in various ways. And that's what the chain rule, product rule, and quotient rule are used for. We're going to start by talking about the chain rule. Officially, the chain rule says we can take the derivative of a composition of functions, f with g inside of it. And when we do, that's going to equal to the derivative of the f function, with g still inside of it, times the derivative of the g function. I like to think about this as saying we're going to take the derivative of the outside and then multiply by the derivative of the inside. Let's take a look at some examples where we're going to do just that. Let's say we've got the function f of x equals the 5x squared minus 7x plus 2, and all of that is raised to the fourth power. What I want to notice is that fourth power is outside of the parentheses, wrapped around the entire other stuff. That is the outside function. So we're going to take the outside function's derivative first. The way we take the derivative of stuff raised to the fourth power is we pull that 4 out front, and then we reduce the exponent by 1. Notice the inside stayed the same. I'm just working with the exponent on the outside using that power rule of polynomials from before. That's the derivative of the outside. Now, sitting inside that fourth power is 5x squared minus 7x plus 2. We're going to multiply by the derivative of that inside function. And using our polynomial power rule, we see that's 10x minus 7. And that's going to give us our derivative of our function. Let's take a look at another example. Let's try f of x equals 4e to the 7x squared minus the natural log of 4x plus 5e to the x. Well, if we're going to take the derivative of this function, we're going to do this one term at a time. I see the outside function on the left side. We've actually got two functions here, left and right. We'll treat separately. The outside function is e to the 7x squared, e to the stuff. So we have constant out front. The derivative of e to the stuff is e to the stuff. Inside of that e to the stuff is a 7x squared. So we're going to multiply by that derivative. The derivative of the inside stuff is 14x to the first. Now we'll go to the second half of the function. Notice on the outside, we're taking a natural log of some stuff with a minus sign. The derivative of natural log is 1 over the stuff, the 4x plus 5e to the x. Then we'll multiply that by the derivative of the inside function, which is 4 plus 5e to the x. Might do a little bit of cleanup. I'm just going to multiply 4 times 14. When I multiply 4 times 14, I get 56. E to the 7x squared minus 4 plus 5e to the x over 4x plus 5 e to the x. That is my derivative. Let's do one last example. Let's do f of x equals the square root of the natural log of 2x plus 3. Well, we might want to rewrite that. We'll rewrite that as the natural log of 2x plus 3, all raised to the 1/2 power, because now I can see the outside function is that 1/2 power wrapped around the entire thing. With an exponent, we pull the exponent out front, times the natural log of 2x plus 3. And then after moving that exponent out front, we reduce the exponent by 1 to get negative 1/2. Then we go inside the function. And inside the 1/2 power, inside the square root, is a natural log. The derivative of natural log is 1 over the stuff, the 2x plus 3. But inside that one is 2x plus 3. And so then we'll multiply by the derivative of 2x plus 3, which is just 2. And so we start on the outside and take the derivative of each layer, peeling it off like an onion until we get our final derivative. That is the chain rule, the derivative of the outside times the derivative of the inside. And our next video is going to take a look at what we call the product rule.